All right, guys, happy Wednesday. Glad you made it another day. This is, I believe, day 8 of at home learning. So today is the last section of chapter 9. It's on right triangle trigonometry. Um, it's uh, it's a nice little brief introduction to your trig functions. I didn't bring home the calculators that I recommended in school, but you're going to learn how to use those sine, cosine, and tangent functions on your calculator today that you've probably been staring at for a while and wondering what those things are. So they are the abbreviated versions of sine, which is abbreviated the SIN, cosine, which is abbreviated with the first three letters COS, and then tangent, abbreviated TAN. So they are a ratio of the lengths of the sides of a right triangle. So as long as a ratio is similar, it works for all right triangles. So all right triangles can use these three trig functions. Um, with your calculators, when we go to use them, you need to make sure that they're in degrees mode. So on your calculator, mine looks different obviously, but there's a button up at the top and it says DRG. Make sure that you push that button and it's in the degrees mode, the D mode. I think it's abbreviated DEG on the calculator. So go ahead and see that you can do that, and then we'll check here in a little bit to make sure that our calculators are spitting out the same answer. If they're not, reach out to me and I'll uh, get it fixed for you. We can do what we need to do. Okay, so the three trig functions can be found by applying the anagram SOHCAHTOA. So SOHCAHTOA is the anagram. That helps you memorize how to use sine, cosine, and tangent, because sine is the side opposite of the angle that you're talking about over the hypotenuse. So it's sine is opposite over hypotenuse. So sine is opposite over hypotenuse. Cosine is the adjacent side over the hypotenuse. So that's why it's CAH. Cosine is adjacent over hypotenuse. And then tangent is the opposite side over the adjacent side. So that's the TOA. Tangent is opposite over adjacent. So you might be wondering, what does that mean, opposite adjacent? Hypotenuse is pretty obvious. So here is what that means. So if you have a right triangle, you're going to be talking about one of the two acute angles. You can't use the right angle when you're doing trig functions. So let's say you were talking about this angle. So this side is clearly the hypotenuse. It has to be the hypotenuse because it's the longest side. It's across from the right angle. But if you're talking about this angle, the opposite and adjacent sides are relative to which angle you're talking about. If you're talking about this angle, the side across from it is going to be opposite. The side that touches the angle makes up the angle that's not the hypotenuse. That is the adjacent side. So we've got the hypotenuse, opposite side is across from the angle. The adjacent side is the side that makes up that angle that is not the hypotenuse. So you'll see, if we were talking about this angle right here, then this side would now be opposite, and then this side would be adjacent if you're talking about that green angle there. So there is where the pieces of information come from. So all you got to do is fill in. If you're talking about sine, it's opposite over hypotenuse. If you're talking about cosine, it's adjacent over hypotenuse. If you're talking about tangent, it is opposite over adjacent. So what we're going to do here is just practice identifying what would be the sine, what would be the cosine, and what would be the tangent. So, and it says of A. So that means this is the angle we're going to be using. We're using angle A. Now you'll notice we're missing the third side of our right triangle. So how do we find the third side in a right triangle? You use the Pythagorean theorem, of course. So we know that the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs, c is the hypotenuse. Looking at our picture, we have the two legs, so we're going to fill it in as 5 squared plus 12 squared equals c squared. That would be 25 plus 144, which is 169, equals c squared. Take the square root, and the square root of 169 comes out to be an even 13. So now that we have the three sides, we're able to find the sine, cosine, and tangent of angle A. So let's start with the sine of A. The sine, remember sine is opposite over hypotenuse. So before we find the sine, let's just label our things and then all we have to do is fill it in. So according to this angle, of course this one up here is hypotenuse. We can start with that one. But according to this angle, the one across from it is going to be the opposite side. And the one that is next to the angle that is not the hypotenuse is the adjacent side. So now we just have to fill it in. Sine is opposite over hypotenuse. So opposite is 5, hypotenuse is 13. So the sine of A would be 5 over 13. So we're not doing anything in our calculators yet. We're just identifying the sides, the ratios. The cosine of A is written like that. So the cosine is adjacent over hypotenuse. So adjacent is 12, the hypotenuse is still 13, so it's going to be 12 over 13. And then the last one, the tangent of A. Tangent of A, so tangent is opposite over adjacent. So the opposite side would be 5, the adjacent side would be 12. So there we've identified the ratios for sine, cosine, and tangent of that triangle. If you want to pause the video and try number 2, that would be good. Again, we're missing that hypotenuse, so if we plug it into the Pythagorean theorem, it'd be 3 squared plus 4 squared equals c squared. So 9 and 16 makes 25, and the square root of 25 is 5. That's the famous 3, 4, 5 right triangle. Again, we're doing angle A, so 5 is, of course, the hypotenuse. Across from it is the opposite side. The side next to it, not the hypotenuse, is the adjacent side. So the sine of A, sine is so, opposite over hypotenuse, 3 over 5. Cosine is ca, AH, adjacent over hypotenuse, 4 over 5. Tangent is toa, OA, opposite over adjacent, 3/4. Okay, down here we're finding the same ratios, just a little more practice with that. This time we're going to go of angle B. So if I'm looking at number 1, angle B, now 12 would be the opposite side, and 5 would be the adjacent side. The hypotenuse is still 13. So the sine of B, sine is so, opposite over hypotenuse, so it's going to be 12 over 13. Cosine of B is ca, adjacent over hypotenuse, so that would be blue adjacent, 5 over 13. And then tangent of B, toa, opposite over adjacent. I'm looking at the blue ones, opposite over adjacent, 12 over 5. So you can see a relationship. You'll notice that the sines and cosines flipped, changed, like this one was the cosine of A, now it's the sine of B. So, and then the tangent is the reciprocal. So that relationship will actually always be true if you're looking at the other angle in a triangle. Again, pause here, try number 2, and then we'll compare. So angle B, 4 is now opposite, 3 is now adjacent. The sine of B, sine is opposite over hypotenuse, so that'd be 4/5. The cosine of B, cosine is adjacent over hypotenuse, that would be 3/5. And then the tangent of B is opposite over adjacent, so that would be 4/3. Again, you see the sine and cosine switched, and then the tangent is the reciprocal. Okay, so now we're going to actually apply our ratios and solve for something that's missing. So that's what the trig functions are useful for. You have to have just a little bit of information, and you can find all of the missing sides of a right triangle. And this is useful for architects, and GPS uses this. Every GPS in your car uses trig functions to triangulate your position, and it locates you on the globe. So very useful stuff, these trig functions are. So let's look. First thing I'm going to do, by the way, these are all going to be right triangles, and C is going to be your right angle if it doesn't say otherwise. So I like to draw a picture of a right triangle. C has to be my right angle, and then you can make A and B, whichever one you want. It doesn't matter. And then if you're given a capital letter, that's going to be the angle. If you're given a lowercase letter, that's going to be the side across from the capital letter version. So in this one, they give us angle A is 62, so we can fill that in. And then they give us lowercase b is 150. So if capital B is here, lowercase b is going to be across from capital B. So lowercase b would be right here, 150. We're asked to find lowercase a. So lowercase a is opposite across from capital A. So this one's going to be A right there. And that's the one we're going to find. So what we can do is use a trig function to find any missing piece of this right triangle. So what we'll do is we'll label, so we're given angle A, so that's the angle we're going to use. We're going to label the two things that we have. So first, I'll do A. Is A opposite, adjacent, or hypotenuse of that angle? So it's obviously not the hypotenuse. It is across from that angle, so this is opposite. So I will write that down. Then the other piece that we have is 150. It's not opposite because we already have that, and it's not hypotenuse because that would be there. This one is the other part of the angle next to the angle, so it is adjacent. Okay, so now all we have to do is figure out which trig function uses opposite and adjacent. So we look for now until we've got them memorized. Which trig function uses opposite and adjacent? And you'll see it right there, tangent, TOA, T-O-A, O-A, right there, opposite and adjacent. So the formula is always the same. It's going to be trig function, angle, equals, and then, fill in the blank, whatever the two things are, right? So we figured out our trig function. It is tangent of our angle, which is 62, equals tangent is opposite over adjacent. So that opposite is A, adjacent is 150. Okay, so this is an algebra problem now. We're solving this equation for A. So how do I get A by itself? Oh, I need to get rid of that 150. What is that 150 doing to that A? It's dividing it. So what's the opposite of dividing? I multiply by 150. If I multiply one side by 150, I have to multiply the other side by 150. So you see that A is now by itself. A is 150 tangents of 62. So once you get A by itself, all we have to do now is pull out our calculator. Make sure it's in that degree mode like I talked about earlier. And then I just type it in just like I wrote it down. Let me see here. All right. So it's 150. You're going to hit that tangent button. It's going to pull up a parenthesis, and then your angle, 62. Be sure to get in the habit of closing that parenthesis. I'm just going to make sure I'm in degrees. Yes. So if your calculator doesn't spit out 282.1, then your calculator is not in the correct mode. And if you can't figure out how to change it, reach out to me or Google it, see if you can figure it out there, whatever you need to do. So it looks like A comes out to be 282.1. So we figured out that this side would be 282.1 if you had a 62-degree angle and the other side was 150. So that is, it's useful for just a lot of things. So we just got a lot of examples of this. We're going to just keep practicing this until we feel comfortable with it. Okay, so again, we have triangle ABC, so I'm going to draw a right triangle. These are pretty easy problems. They go pretty quick once you get the hang of them. C has to be the right angle. I'll make A that one and B this one. Okay, this time they give us angle A to be 62 once again. B, the side across from angle B, is still 150. This time we're finding lowercase c, so that would be across from angle C right there. Okay, so we've got our picture drawn. Now all we have to do is fill in. According to this angle, we know that C has to be the hypotenuse. Is 150 the opposite or the adjacent side of this angle? It's not opposite because that would be across from it. It is the adjacent side. So then your formula again is trig function of your angle equals whatever the trig function is. So which trig function uses adjacent and hypotenuse? So you think of SOH, CA, TOA. Which trig function uses adjacent and hypotenuse? You see it right there, A and H, adjacent and hypotenuse. So that's C for cosine. So it's going to be the cosine of our angle, 62, equals cosine is adjacent over hypotenuse. So that would be 150 over C. So that means we have to solve that equation for C. So again, if I have a fraction in my problem, first thing I got to do is get rid of the fraction by multiplying by the common denominator. So I'm going to multiply one side by C, which means I need to multiply the other side by C. Those C's cancel each other out on the right side. So I'll write this one down. C times the cosine of 62 equals 150. What's the last thing I have to do to get this C by itself? Well, if that C is being multiplied by a cosine of 62, we're going to divide this side by the cosine of 62. If I divide the left side by the cosine of 62, I have to divide the right side by the cosine of 62. Those on the left cancel, and it looks like C equals 150 divided by the cosine of 62. So that's a lot more work than the other problem. So here's what I remembered. I remember that if my variable is in the denominator, these two things are just going to end up switching places, and you'll see that's what happens. So let me just draw that little arrow right there. These two things just switched places. See, the C is now over here. The cosine of 62 is now in the denominator. So that's what I remember. If the variable is in the denominator, those two things will switch places when you solve it algebraically. That way I don't have to go through all these steps. I just know that's what's going to happen. So now that I've got C solved, I just pull out my handy dandy calculator and type it in just like I see it. 150 divided by the cosine of 62, close that parenthesis, and then round it to the nearest tenth. C comes out to be 319.5. The length of that hypotenuse would be 319.5 about. Okay, let's do a couple more. Okay, we've got triangle ABC once again, so let's draw a right triangle. C is the right angle. I like to put A there and B there. You can change it up if you want. This time they give us angle B is 40. Lowercase b, that's the side across from capital B, is 140. We're asked to find lowercase a, so that would be over here across from capital A. So we label this angle. According to this angle, is 140 opposite, adjacent, or hypotenuse? It's not the hypotenuse, it's opposite, it's across from it. So we've got opposite, and then according to this angle, is A opposite, adjacent, or hypotenuse? Definitely not opposite. We know the hypotenuse is over here. This is the adjacent side. So then I just look, I pull it up here. Which trig function uses opposite and adjacent? Which one has O and A? Tangent does. Tangent has opposite and adjacent. So that's the trig function we'll use. Tangent of our angle, this time it's 40, is equal to the opposite side, 140, over the adjacent side, A. So here's that scenario we just had. My variable is in the denominator, so I know if I were to solve this algebraically, these two things are just going to end up switching spots. So I'm just going to do that because I know that's what's going to happen. A is going to equal 140 divided by the tangent of 40. So I can just go directly to that answer if I remember the shortcut. Otherwise, I just have to solve it out algebraically. So we've got 140 divided by the tangent of 40. Rounded to the nearest tenth, it's going to be a 166.8. 4 does not round it up. Now would be a great time to see if you can find C in that next triangle, which is really the same triangle as before. So try that out. Pause it in here. Okay, let's see how you did. A, C, B, right angle. All right, angle B is still 40. Lowercase b is still 140. This time we're asked to find lowercase c. So according to this angle, 140 is still going to be opposite. C, of course, is going to be the hypotenuse. So which trig function uses opposite and hypotenuse? So sine. The sine of 40 equals the opposite over the hypotenuse. Again, my variable is in the denominator. So I know if I were to solve this algebraically, they'll just switch places. So I just do that and don't mess with the algebra. 140 divided by the sine of 40. So we're going to type that in. 140 divided by the sine of 40. Close that parenthesis. 217.8. Rounded to the nearest tenth. Awesome. So you can see these aren't too difficult. It's usually a 1 or 2 step algebra problem, not that bad. Another type of problem you'll see is when you're looking for a missing angle. So when you're looking for a missing angle, you have to use the inverse trig function on the calculator. And I'll show you how to do that once we set up this next problem. It's not hard. So again, start by drawing your right triangle. C is the right angle, and then A and B are the other acute angles. Lowercase a is 12, so that's the side across from capital A. Lowercase b is 14, that's the side across from capital B. We're asked to find capital A, that's angle A, so this is what we're looking for. I'm just going to call it A since that's what it is, right? Okay, so mark that angle, put a little A in there. So according to that angle, so we're going to do the same thing here. According to this angle, is 12 opposite, adjacent, or hypotenuse? It is, of course, opposite. And 14 is adjacent. So then again, which trig function uses opposite and adjacent? So again, it's tangent. So it's the tangent of your angle. This time we don't know our angle, so it's going to just be that capital A equals the opposite side over the adjacent side, 12 over 14. Now you don't need to reduce that fraction. Don't worry about it. It just does it. So this is where what I was talking about comes into play. We're looking for an angle. So we use the inverse trig function. So the inverse trig function looks like this. A equals, we take the tangent, move it over there, and it gives this little exponent of a -1. So the inverse trig, or the inverse tangent of 12/14. So let's see if we can find that on our calculators. Look for your trig functions. I know yours looks a little bit different than mine, but look right above tangent. You see it right there in light blue? And the cosine inverse function and the inverse sine function, they're all right there above your trig function button. So how do you get those? Do you remember? You hit that second button first. Now it's not a shift key, so don't hold it down. Just press it and release. And then you hit, we're looking for the inverse tangent. So you'll notice on your calculator, you've got the little -1. So now we just type in what we see. We have the inverse tangent of 12 divided by 14. So 12 divided by 14. Again, close that parenthesis, get in that habit. So we're going to round that. That's the angle right there. That's all you have to do. Round the angle to the nearest tenth. It's going to be about 40.6. Next one. If you want to try this one on your own, that would be great. Pause your video, try it out, see if you can figure it out. Okay, this time they give us lowercase a to be 32, lowercase c to be 19. We're looking for capital B, so this angle here, and I'll write a capital B in there because I don't know it. So according to that angle, 32 is going to be adjacent. 19 is going to be the hypotenuse. Which trig function uses those two things? That's cosine. So it's the cosine of our angle, which is capital B. Cosine is C-A-H. A-H, adjacent over hypotenuse. 32 over 19. If I'm looking for an angle, which I am, that means my angle is going to be my inverse cosine of that 32/19. So all I have to do is pull out my calculator and type it in. A lot of calculator work on this trig function stuff, so you should like it. 32 divided by 19. Close that parenthesis. Uh-oh. What's the issue? It didn't like that. Did I set up something wrong? Oh, yeah, my problem was set up wrong. You're probably freaking out if you tried that on your own. The hypotenuse can't be shorter than the leg, so this was a bad problem. Typo. I need to make a note of that and fix that. Sorry, guys. Hopefully that didn't scare you too much. So what we're going to do with this is we're going to draw a little bit of word problem type things, not too bad, and we're going to draw the pictures out and figure out what they're asking us for. So let's look at this example. From a point on level ground 125 feet from the base of a cell tower, the angle of elevation to the top of the tower is 57.2 degrees. Approximate the height of the tower to the nearest foot. So this is interesting. You could go outside of your house and figure out how tall is your house by using a trig function. So we'll show you how to do that right here. So we've got a cell phone tower. Looks like this, right? Something like that. So we got a cell phone tower. We are standing 125 feet from that cell phone tower. We have one of those little angle measure things, and we look to the top of that cell phone tower, and that angle measure thing says it's 57.2 degrees to the top of that cell phone tower. We want to know how tall is that cell phone. So you see what we've drawn there? It's a right triangle, isn't it? So let's look at that right triangle. It's got an angle of 57.2. We know we're 125 feet from that cell phone tower. We want to know how tall is that tower. So according to that angle, is x opposite, adjacent, or hypotenuse? It's opposite. And 125 is adjacent. Which trig function uses those two things? Tangent. The tangent of our angle, 57.2, tangent is opposite over adjacent, x over 125. Nice, easy algebra problem to solve. To get that 125 to the other side, we would multiply by 125. So we stick it out front there. X equals 125 tangents of 57.2. We pull out our calculator and we type it in. 125 tangents of 57.2. Close that parenthesis. Rounded to the nearest tenth. Oh no, rounded to the nearest foot, it says. That'd be 194 feet. That cell phone tower is about 194 feet high off the ground. Okay, let's look at another example. We got a flagpole. We know how tall the flagpole is because we put it in that yard. Look at that beautiful American flag in green. Okay, so we got a flagpole. We know how tall it is because we put it in the ground. It's 14 meters tall. Right now, we can also measure the shadow that it's casting on the ground. The shadow is 10 feet long, or 10 meters long, excuse me, somebody's metric. I guess I should have drawn like a UK flag instead of an American flag. Anywho, oh man, I'm getting long on this video. Let's go through this quickly. It says find the angle of elevation to the sun. So the sun, of course, would be somewhere back here if the shadow's over here. We want to know how high is the sun in the sky? What degree is that angle to the sun? So you see our right triangle, right? Look at that angle. According to that angle, is 14 opposite, adjacent, or hypotenuse? It's opposite. And then the 10 is adjacent. So once again, opposite and adjacent is going to use our tangent. The tangent of our angle, this time we don't know our angle, is equal to opposite over adjacent. If I'm looking for an angle, remember that we're going to use our inverse tangent. So it's the inverse tangent of 14/10 to find the angle. Second tangent, 14 divided by 10, rounded to the nearest degree, 54.4 would round to about 54 degrees. So the sun is 54 degrees in the sky. These two down here are the same as above, so it's a good time to pause the video and try that. Let's see, from a point on level ground 80 feet from the base of the Eiffel Tower. I don't know what the Eiffel Tower really looks like. It's something like that, though. We are standing 80 feet from the Eiffel Tower. We look to the top of that Eiffel Tower. We also have one of those angle measure things, and it's 85.4 degrees. How tall is the Eiffel Tower? And then you can look this up on Google and see if I made my problem right. So there's our right triangle. According to this angle, x would be opposite, 80 would be adjacent. Which trig function? Oh my goodness, tangent again. So the tangent of 85.4 equals opposite over adjacent. Get rid of that 80 by multiplying. Type it into your calculator. 80 tangents of 85.4. 994 feet. It's about 994 feet. See if that's close. Leave me a comment. Subscribe. That's what they say on YouTube, right? Leave me a comment if it's right. Somebody do it. I want to know if that's right. And then here we go. This is what you can do at your house if you wanted to find how high the sun is right now. Is it even sunny today? I don't know. We got a building. It's 21 feet tall. It casts a shadow. It's 25 feet long. How high is the sun in the sky? X right there, angle. What degree is it at? All right, so again, 21, opposite. 25, adjacent. I see a pattern here. Tangent of our angle is equal to the opposite over the adjacent. Inverse tangent, once again, of 21 25ths. 40 degrees. All right, there's the last problem. Sorry the video was so long today. Just a lot of stuff, got to make sure you're all good with this. If you need any help, please reach out. I'll be happy to help you out. You're going to do great at this, though. You guys are smart young whippersnappers. I'll talk to you later. Have a great day, and enjoy.